Okay, everybody, this is chapter 8, section 1. This is the beginning of trigonometry, which everybody, this is 8.1. This is the beginning of trigonometry, so we're going to do a little bit of review on the Pythagorean theorem, just because trigonometry is based on a right triangle that is kind of the same as what the Pythagorean theorem is, okay? So in theorem 8.1, and you don't have to write down the 8.1, but the theorem is in a right angle, the square of the length of the hypotenuse is equal to the sum of the squares of the legs, okay? So if you write that down, if you also go ahead and write down the Pythagorean theorem, okay? And let's just remind ourselves that the C is the hypotenuse, okay? Oh, pen doesn't want to work today. That happened last time, okay? So you got to make sure that you identify in the right triangle where the hypotenuse is, and either you might have to find it, or is it something I have, and make sure you substitute stuff in correctly, okay? One of the things too that they kind of work with in this section is Pythagorean triple. And that's when three integers satisfy a squared plus b squared equals c squared. Now, integers might be a little bit more understandable if you replace it with the word whole numbers, okay? And they're obviously they got to be positive, okay? So over here on the side, we have some numbers that their values are whole numbers positive, and they satisfy a squared plus b squared is c squared, okay? So if you could write these down, because these are ones that would come up a lot as we go through this chapter, and just something you need to be aware of. It makes things a little bit easier if you know this list. Most of them you will probably get more than once, especially these first few, okay? So if I have, just an example, if I take that first set of numbers, 5 is the biggest number. Now remember, the hypotenuse has to be the longest leg of a right triangle. So if I took those measurements, that 5 is going to be my C, and those three numbers make that statement true. 3 squared is 9, 4 squared is 16. So 9 plus 16 is 25, and 5 squared is 25, okay? The second one, which is one that we get a lot too as we kind of go through things, is this. I'm going to make sure that 10 is my C because it's the longest leg and what they've given me. 6 squared is 36, 8 squared is 64, 36 plus 64 is 100, and 10 squared is 100, okay? So those two you'll see a lot as we kind of go through chapter 8, okay? The next one is another one that shows up quite a bit. I won't write down, the a squared plus b squared equals c squared. Those first two, I hope you're just kind of understanding the idea here. But those three numbers, when you plug it in, are all whole numbers basically, and they make it true, okay? So after that, it kind of gets some numbers that we don't really get into a whole bunch. You might see them once in a while in what we do, okay? So those are common Pythagorean triples. The first three, you'll see those, and if you're studying and you're being kind of focused on what we're doing, you might be able to just recognize them for what they are, and then it's a pretty easy problem, okay? All right, so if we take these really quick, if you draw these two triangles and label them up and understand what we're trying to find, and I'll kind of, if I go too fast again, just pause the video and get caught up with your notes and hit play again, okay? But this first one, if I draw, an arrow from the right angle to the opposite side, there's your hypotenuse, okay? And, then I've got 5 squared plus 12 squared equals c squared, because I don't have the hypotenuse. But if you take a look, that if I got two legs that are 5 and 12, that means the third leg of the hypotenuse has to be 13. Okay, but let's just do the math here and see what we get. I got ahead of myself here. Hold on. Okay, 25 and 144 is 169 equals c squared. And at this point, remember, if we want to get c all by itself, we take the square root. So you want to use your square root button on your calculators for right now. We'll do some simplifications later on, but that comes out to be 13. Okay, so that's a Pythagorean triple, and that's what it was kind of asking. Is it? Your answer would be yes. Okay, so that's how you want to do that. All right. Taking example B, if you take a look at that, there's my C. Well, now they're giving it to me. Okay, so I'm going to go 7 squared. I'll go the other side's x squared. That's what they got labeled, and it's 14 squared. Okay. So if you look at this list of Pythagorean triples over here to the right, I'm not seeing anything that's got a 7 in it or a 14 in it. So, if I know that list relatively well, then I probably go, well, I got to at least find out what is the variable, because that it is asking me to do that. But right now my answer is no, it's not a Pythagorean triple. Okay. So I'll let you guys go ahead and do the math on that and see what you get, and get to the decimal to the nearest tenth on that when you get it. Okay. Okay. So x equals approximately 12.1. That's not a Pythagorean triple because this number is not whole. Okay. All right. So we go down to this next example. If you guys could go ahead and draw that and label it, and they want me to find the area to the nearest tenth. Okay. So it is a trapezoid. So let me write this down so you got it. We've done this before, but sometimes we don't always remember this particular formula. So I would do that. The height needs to be vertical, so that would either be this, or sometimes you'll see it drawn inside of it like this. Either one's the same. Typically the top is B1 and the bottom is B2. Okay. So, and this is a question that shows up a bunch. You might want to label this as a test question. It's just making you take what you know of something already and applying it to this. I need the height, okay, and I don't have it. But if you use this, what I've drawn here over on the right-hand side, or left-hand side, sorry, I've got a right triangle here because I had to draw this, vertically, okay? So what I could do is, using the top and the bottom, I could use that this segment right here is 6, and this now becomes 10, okay? And now I've got a right triangle here over on the left side, and I've got my hypotenuse is 10. So my height is what I could use Pythagorean theorem to do that, okay? So we'll go ahead and do that. Like I said, 10 was my hypotenuse. And this is where I kind of was talking a little bit earlier. Again, if you know your Pythagorean triples, you might recognize if the hypotenuse is 10 and one of the sides is 6, hey, that was like the second one on our list. So B should be 8, but let's do our math, because maybe we didn't remember that or get a chance to study it yet. So I'm going to get that. I'm going to subtract 36 from both sides. Sorry, 36 from both sides gives me 64. take the square root of both sides, and I get 8. Okay, so if you know that list, then I can do some of that, or hey, I know it should be 8 right off the bat, but doing the math wasn't too tough. So the height is now 8, and I can go ahead now and take my B1, which was 10, my B2, which is 16, and now I found my H is 8, okay? And I can plug it into my formula right here. Sometimes you can't remember the formula, but remember I got a triangle on the left-hand side, I got a rectangle on the right. I could find the area of both of those and then add it together. Okay, so I'm going to let you guys decide what you want to do. Why don't you go ahead and do your math and find the area of this trapezoid, okay? So if you want to hit pause, then come on back. Okay, so there you go. You get 104 meters squared as the area of that. Sorry about that. Should be 2. Onward. Let's go. Sorry about that. Okay. All right. So applying some of what you learned, being able to identify Pythagorean triples, or just use the Pythagorean theorem. Okay. Okay. So this is kind of well, I think it's cool, but I guess then you can call me a math nerd, whatever. This is kind of a cool way to prove the Pythagorean theorem. Okay, so let me set this up a little bit and have you copy it. If you could kind of draw that, it's a square within a square. Okay, so if you can go ahead and draw those two things, and then we're going to label them up a little bit. Okay. Okay, so let's make some things kind of understood here. It's a square within a square. So I've got two squares. Things we know about squares. One, all the sides are the same, and all the angles are 90. Okay, so what I'm going to show here is that this angle and this angle is 90. And then the same thing on the inside. And the one on the inside, it doesn't really matter, but we're just making sure we understand the situation a little bit, okay? Now, if you really look at the outside square, and now I got the inside, what you create these triangles out here, and so if I got a triangle and I got the sides of in this case, the blue square inside, the sides become C because they're opposite those right angles. So let's go ahead and label those, okay? All right. And then taking these right triangles that are really in red here, we're going to label them with the other terms that we use for the Pythagorean theorem. Now, typically in the book, historically, the short side of a right triangle is A in the Pythagorean theorem. So let's go around and label the short sides of these right triangles A. Okay, and then the middle leg is typically labeled B in the Pythagorean theorem. Okay, so we'll go around and do that. Okay, so hopefully you understood that. The blue square is really kind of dividing the red square up into right triangles, kind of like at the corners, okay? So now what they want me to do is prove the Pythagorean theorem, okay? So what we want to do is we want to find the area, and there's no numbers here, so you got to think a little bit outside the box here. There's no numbers here, but let's find the area of the small triangle, okay? oh, I'm sorry, I keep saying triangle, I think, the small square. Okay. Now, to get the area of a small square, it's either the length times the width or the base times the height, whichever way you want to do that. Now, the small square is the blue one. What are its sides? And the sides are C, so it's C times C, which gets me C squared. Okay? What we're going to do is we're going to find the area of the triangles. Okay, so the red triangles. The area of a triangle is, and I usually use the base times the height divided by 2 is what I use. Okay, so let's take we'll use this triangle here, and I hope you guys all agree the triangle should be the same. Okay, so we're going to take, and once again, we're not using any letters or any numbers, we're using letters. So it's A times B divided by 2. Okay, that's really all I can do with it, but I've got 4 of them. So I'm going to go ahead and multiply that by 4. Okay, and the 4 and the 2 are going to kind of cancel a little bit. I'm going to get that. So really the area of the 4 triangles is 2AB. Okay. So this is where it gets a little tricky. What does the area of the big triangle equal? Okay. Well, if I really think about it, the big triangle is made up of the 4. I'm sorry, I keep saying triangle. The big square. What can I use to represent the big square? And I've already found kind of the areas that make it up. I found the blue square and I found the 4 red triangles. So here was the blue square. Here are the 4 triangles, and really I could say the big square is equal to the small square plus the 4 right triangles. Okay, the 2 things I found earlier. Okay. All right. But what's another way I could find the area of the big square? Well, I could go back up here, like the small square was that. It was the length times the width, or the base times the height, and maybe I could use that. So let's do this. If I look at the base here, you know, what can I, you know, I got those letters there. How can I use those to represent the base? Well, they're 2 line segments, okay? Let me get a different color here. These are 2 line segments, and can't I add 2 line segments together to get a bigger line? And I can. So my base is going to be A plus B. Okay? And can I do the same thing with the height? You know, it's 2 line segments. Can I put them together? Well, I can. So my height is going to be A plus B. Okay? So can I use those to find the area of a square? And I can go back up here to my formulas, and I can go the base. Remember, I'm using expressions, but math lets me do that, and the height gets me that. Okay. So the area of the big squares, I can also find it this way too. So remember, I'm going to have to FOIL this. Okay, so I'm going to go A times A is A squared. A times B is AB. B times A is AB. And B times B is B squared. Okay? And then I can go ahead and I could, I can put these two terms together. So 1AB plus 1AB is 2AB plus B squared. And that's another way to represent the area of the whole thing, the red triangles and the blue square put together. That's just the whole area, okay? Good? So what I'm going to do then, I've actually got two things that represent the area of the big square. I got what we just did, and then back up here, I did it with just adding all the pieces together, so they should be the same. And if they're the same, I can set them equal to each other. Okay. And in the past when we teach this, we do all this math, the kids are kind of getting kind of lost, because there's no numbers there basically, and they're kind of going whatever. And then I get down to this point and I show, hey, I've got two different expressions that represent the same thing, so they can be equal to each other. Now, what can you do with what I got right here? Okay, and simple math says, well, if I got the same thing on each side, can I subtract it? Well, I got a 2AB on both sides, and if I subtract that, I then end up with A squared, they go away, plus B squared equals, they go away, C squared, and what do you got? You got the Pythagorean theorem, okay? So, I don't know, it's kind of cool how you can kind of do that and prove it. I don't know if it's really a proof, but kind of a neat way to be able to do that one, okay? All right. On example number 4, draw an isosceles right triangle properly. If the hypotenuse is 18 inches, let me get to this by itself. Kind of messed it up here a little bit. What is the length of the leg? And they're giving me 9 square root 2. Okay, so this is a really good question. We've just got to use this. It's really going to be for a couple of sections that we're going to do through chapter 8. So one we got to know, what does isosceles mean? Okay, so if we remember our stuff, we talked about this. It's just two sides with the same length. Okay, so we're going to draw a right triangle with two sides being the same length. Now I got to remember too, what does the word hypotenuse means? Hypotenuse means it's the longest leg. So does that mean I can have two legs are the same, both them being the longest? And I can't. Okay, so what I'm going to have here is the hypotenuse, and these two legs are going to be congruent to each other. Okay, and they said draw an isosceles right triangle, so I'm showing that it's right. Okay, so if I've got a right triangle, I can use Pythagorean theorem again. A squared B squared equals C squared. Okay, but they're giving me the hypotenuse. Okay, so I can go, and I'm going to change this up. So this is what you have to be able to remember too to do. If both of these A and B should be the same in this particular instance, I can't really put those in the Pythagorean theorem with C being 18. But because they're both the same, I could call both of them X. Okay, because they should be equal if it's isosceles. So instead of A squared and B squared, I can go X squared plus X squared equals 18 inches squared. Okay. And then I can go and try to solve this. So 1x squared and 1x squared, 2x squared. 18 squared is 324. And then how am I going to solve this for x now? And I think I should be able to first divide by 2. okay? And that's going to leave me with x squared equals 162. And then hopefully remember, because you have to do this a lot, take the square root to solve for x. And we'll round this to the nearest tenth. And I believe you get something close to about 12.7. Okay. All right, so that's a question that shows up a bunch, situations, different things that we kind of put some real life examples with this that type of problem. So hopefully we can do that, all right? So why don't you guys go and do number 5, please. It's it's the same thing. You got a square. We're going to assume that it's a square, okay? So that means all the sides are the same. But really it's just 2 right triangles, and they're both isosceles, okay? So that 5 is the hypotenuse of whichever triangle you want to deal with. And this question is exactly like the one we just did, except now my C is a different value. So you want to set it up exactly the same way, except, change C to something different, okay? So I'll let you guys do that. But then they want you to find the areas, or they want you to find the area and the perimeter. So you're going to have to use that. Whatever answer you get, it's not the end. It's just the beginning of what you have to get. Okay. So if you want to hit pause and go do those, and then we'll come back and do these together. Okay. Round your answers to the nearest tenth. Okay. Okay, so you set up the problem exactly the same way, like I said, except the hypotenuse is a little bit different. Now it's 5. So plug everything in, and each of the sides should have been the same because it's a square. So you get 2x squared equals 25, and divide that by 2, you get x squared is 12.5, and you take the square root, and I think it was approximately 3.5. But then you have to find the area, so 3.5 times 3.5 should give you 12.5. And then I got 4 sides that are approximately 3.5, so multiply that by 4, and I get 14 for my perimeter, okay? Now there's some rounding issues there, just to kind of making it a little bit simple, and just kind of a problem that you're going to get a bunch as we kind of move through stuff, okay? Okay, so if you guys could do the converse of the Pythagorean theorem, this is a kind of a test question, and it's just saying what we know as the Pythagorean theorem, just doing the converse, okay? And it says that the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other 2 sides, and the triangle is right, okay? So basically what it's asking you to do is to take, we're going to give you all 3 sides, and you just plug it into the Pythagorean theorem and see if, does it come out to be equal is what you're trying to find, okay? So, I'm assuming that this side's the C, or the hypotenuse, so I'm going to take the 8 squared plus 7 squared equals square root of 113 squared. Okay, don't forget that, please. Okay, and we'll do some math. So 8 squared is 64, 7 squared is 49. And let me kind of explain this really quick. When you have this radical square root of 1, or the radical 113, or the square root of 113, there's a little 2 right there. We just don't write it in there because if nothing's there, we're assuming we want you to take the square root. Sometimes, you know, in some other math that we do and you do next year, we might ask you to do different roots, so we have to tell you that. So we might, you know, put a different root. This just means what number times itself 3 times gives you what's inside. Same thing with this one. How many times do you multiply? What number you multiply together 4 times to get what's inside? Okay. But when you have something like this, you're squaring a square root. It basically makes these 2's cancel each other out, and you're just left with what was inside the radical. Okay. So hopefully you know that. If you didn't, well, now you do. You got to remember it because it will show up. Okay. And then when I multiply 64 and 49, I get 113. So that triangle is a does represent the Pythagorean theorem. Okay. All right. So once you try the other one, the other one's a little trickier. Okay. I'm assuming that this is my C. Okay. So I'm gonna square this whole thing. So you got to be careful with this. This is some pretty good math right here. Okay. And then I've got 15 squared and 36 squared. My pen's not working. Okay, now, let me just kind of explain what you're doing out here at C. You got to square the 4, and then when you square the square root of 95, what do you get? Oh, it's similar to what happened here. So there's really 2 little things you got to play with there inside the parentheses, okay? So I'll let you guys do that real quick. See what we get. If you want to hit pause and then come back, we'll get going, all right? Okay. So there you go. When I do my math, I do not get the same thing on both sides. So this is no, it's not a right triangle. So that's kind of what you're trying to prove. Is it a right triangle or not? All right. Over here, just let me kind of go over this again. I had to square both things. It's kind of like I had to distribute that exponent too. 4 squared is 16. Okay. The square root of 95 squared is 95. Okay, so we got to get that down, and then you multiply those 2 things together and you get 1,520 on the right hand side. Okay, so that's how we got those 2. Okay, here we go. Down here, another important thing, you don't have to do this theorem 8.3. Okay. But this is when it's not a right triangle, when the sides don't add up to being right. Then I got to label it something else, okay? So if the square, the longest side of a triangle, is less than the sum of the squares of the lengths of the other 2 sides, then the triangle is acute. Now remember what acute means, okay? It's not the math teacher. It means that all angles are less than 90 in that triangle. Okay, so this is a big deal. We defined acute way back in the first semester. We have to have it again. Okay, and that's taking the converse as it was, and then when it's not right, then I got to call it something else. So let's write this down. What the theorem's really saying is if you got a squared and b squared, okay, it's going to be greater than c squared, makes this acute, okay? If you want me to read it backwards, let's start with c and read it backwards. C squared is less than or equal to the sum of a squared plus b squared. That's pretty much what the theorem was saying. I just wrote it in Pythagorean theorem form, okay? Let me fix that a little bit. Okay? Now, there are triangles, though, that have angles that are bigger than 90 degrees. So let's read the next one. We don't have to write theorem 8-4, okay? If the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. Now remember, this one is an angle is greater than 90 degrees in the triangle, okay? So let's write this down now. In Pythagorean theorem form, the sum of a squared and b squared in this case will be less than c squared. Okay, the sum of a squared plus b squared would be less than c squared. But let's read it backwards because it's that's the way. This is the converse. The square of the hypotenuse is greater than the sum of the other two sides. Okay. So make sure you write that down because this comes up and this is pretty, in my opinion, pretty easy stuff. But if you really don't know how to write the, let me fix this too, I accidentally erased it. Okay, if you don't understand the inequality signs, you're going to mess those up. Okay? All right. So we got some funky stuff here on this one. Not sure what we're doing here. Okay. So we got three choices. If you could write these down really quick. I'm not going to try to open these up in this one. Someone's messed around with it. Write down these three values for the three sides of maybe a right triangle. Okay. So we got this. So you got A and B and C. So you're going to plug those in the Pythagorean theorem. You're going to tell me if it's right, and if it's not right, will it be obtuse or acute? Okay. The second one, we're going to go ahead and we got some decimals here, so just make sure you're putting that in right. Once again, put it into the Pythagorean theorem. If it comes out to be equal, then it's right. If it's not equal, then you got to determine is it obtuse or acute. All right, the last one, I just want you to be careful with. We're trying to mess with you here on this one, okay? Okay, remember what the Pythagorean theorem is and how it's set up. C is always the longest side. We're kind of lulling you guys into sleep with the first two. So you got to be on your toes for this last one. Identify C first. Once again, plug it into the Pythagorean theorem and then see if it is right. That's when it's equal. If it's not equal, then is it either obtuse or acute? Okay, so if you want to hit pause and do these really quick, plug them into your calculators and see what you get. Round everything to the nearest tenth, and then we'll come back and see what the answers are. Okay. So taking a look, I didn't write out the Pythagorean theorem on these. I just wrote out what I got from a squared plus b squared equals c squared. So the first one, 73 is the a squared plus b squared equals c squared. 7396. So no, it's not right. And because the c squared is bigger, it's greater than the other two, it would be obtuse. Okay. The second one, I get 1442.6 is not equal to 1406.3. So it's not right, but c squared is less than a squared plus b squared, so therefore it's acute. Okay, now the last one you had to be careful. That was your C. Okay, so we kind of got, the first two we put them all in order for you, but this last one we reversed it a little bit. So I get 9,409 equals 9,409, so therefore it is a right triangle. Okay, all right, let's finish this off. This is kind of where you use Pythagorean theorem. And typically you probably use a tape measure anyways. But anyways, we're going to make a foundation to build something on. And we're hoping that the foundation, in this case, I hope it's rectangular. Remember, rectangles have 4 90-degree angles. Even though that looks like a parallelogram to me, it's supposed to represent a rectangle. Okay. I put stakes at all 4 corners and I measured it out. I'm hoping that it's 72 feet by 30 feet. And what I would do is I would take my tape measure and I would measure from here to here and also from here to here. With it being a rectangle, with a parallelogram, this doesn't work. But with it being a rectangle, I'm going to hope that I get the same measurement both ways, okay, or both diagonals, all right? So what we're going to do is we're going to take the two sides, 30 squared plus 72 squared, and we're going to equal it to be c squared, okay? And we're going to call the diagonal c. So I'll let you guys do the work, and let's see if we get 78 for that. Okay, take the square root of that, and I get 78. Okay. All right, so just this section really kind of getting us back to Pythagorean theorem, messing around with it, and kind of getting us back into right triangles, because this whole chapter is based on that. Okay. A lot of these things will show up again, so make sure you go back over it. Also, let's make sure we got our calculators for the next few sections, because you'll need the trig functions, sine, cosine, and tangent. All right. Do a good job on your homework. Should be fairly easy. If it's just a word problem, make sure you draw it out. Make sure you understand it's probably going to be a right triangle. And if you got any issues or questions, please make sure you get a hold of me. Okay. Thanks.